Let's just discuss this a bit so that you will see the difference between us and our ancestors. They were remarkably healthy. Now, in the production of energy, you need magnesium to produce ATP. ATP, adenosine triphosphate, is the chemical energy of the body. You need magnesium in the synthesis or in the production of ATP in your body. If you depend on fruit and vegetables that you buy from the market, if these fruit and vegetables have been cultivated with fertilizer, you are most likely going to be low on magnesium. And if you are low on magnesium, you are going to have high blood pressure, you are going to have diabetes, most likely you are going to have issues with systemic inflammation. Your blood pressure is your blood cholesterol is likely going to go high. Hello, if you were asked between salt and sugar, which one makes more contributions in the development and progression of high blood pressure, what will be your answer and why? Well, it will depend on a few things, especially which doctor you have been listening to. We are going to discuss that extensively today. And also we are going to show you publications from eminent scholars like Professor Richard Johnson of the University of Colorado. He is a professor of nephrology. Nephrology is that field of medicine that is concerned with the study of the kidney. His answer is going to surprise you. In fact, it may not be exactly what you think. Now, another way of rephrasing that question is this. Do you think between salt and sugar, which one do you think was more readily available to our ancestors? And do you think they had high blood pressure in high prevalence in their time? This is the famous Pink Lake in Senegal. From this lake is very salty, and they have a rich supply of salt from this lake, and they have done this for 1,000 years. High blood pressure for those ancestors, they didn't have a rich supply of pharmaceutical drugs. Have you ever wondered how they were able to manage their high blood pressure? In fact, I hope you know this, that at the turn of the 20th century, in the year 1900, the leading cause of death worldwide was not cardiovascular diseases. In fact, it was diseases of infection. Today, we now have cardiovascular disease top the chart, and these disease conditions, these chronic disease conditions, are conditions of inflammation, not of infection. Now, to show us how our ancestors fared, to show us that our ancestors did very well in managing high blood pressure, this is a publication by a British doctor when he came to Africa, particularly Uganda, in the 1920s. This was published on Lancet in 1929. The reason we will spend time to show you scientific publications is because these are peer-reviewed journals. These are academic peer-reviewed journals, which before it was published on these journals, it has been reviewed by eminent scholars, medical doctors who are in the best position to question these assertions. Now, a British doctor came to Africa in the 1920s and published his findings on Lancet, which is a British medical journal, in 1929. It's entitled "Blood Pressure in the African Natives: Its Bearing upon the Etiology of Hypertension and Arteriosclerosis." Again, in 1999, a team of American doctors came to Nigeria. 3 of them, in fact, one of them is a Nigerian. His name is Dr. Charles Rotimi. He and 2 other American doctors came to Nigeria. They were studying the impact of genes on the prevalence of high blood pressure among both the Black Americans who share the same genes as the Yorubas, and also the Yorubas in southwestern Nigeria. So when they checked the black Americans in the US who were carried to the US through the slave trade, they share the same genes as the Yorubas. Whereas in the US, they have a high prevalence of high blood pressure among their adult population, as high as 33%. But when they came to Nigeria, they were shocked that it was only 7% prevalence. In the first week of February in 1999, they published their findings on Scientific American, and it was entitled "The Puzzle of Hypertension in African Americans." And look at their caption. They said genes are often invoked to account for why high blood pressure is so common among African Americans. Yet, the rates are low in Africans. This discrepancy demonstrates how genes and the environment interact. In fact, the data they collected from southwest Nigeria was from a very interior village in Ondo State, very interior village where they were still living in harmony with nature, just like their ancestors. And they were these doctors from the US were shocked that the prevalence of high blood pressure among these African natives was just as low as 7% in their adult population. So I want us to take it as a fact that our ancestors did not have high blood pressure as a prayer point. Now, what was their secret? One of them is their farming mechanism, their farming method. In their time, they practice shifting cultivation. When they cultivate this soil this year, they will leave it for about 4 or 7 years before they cultivate on that soil again. They allow the soil enough time to rebuild its organic matter and also replenish its nutrient density. The fruit and vegetables planted on such a soil and the ones that are planted on the soil today, which we cultivate every year, they are not exactly the same. Again, because we till our soil every year due to rural urban migration, due to overpopulation, due to mechanized farming, we are constantly tilling the soil, and this leads to the loss of nutrients by way of leaching. And most importantly, our ancestors did not use fertilizer. In 1978, Professor L.G. Lombin of Ahmadu Bello University in Zaria published this paper on the Journal of Soil Science and Plant Nutrition. It was entitled "The Evaluation of the Magnesium Supplying Powers of the Nigerian Savannah Soils," in which Professor L.G. Lombin warned us about the coming of fertilizer. He said when you apply fertilizer on a soil, you will distort the potassium magnesium cation exchange. You will favor the preferential absorption of potassium, and magnesium absorption will suffer. So if you depend on fruit and vegetables that you buy from the market, if these fruit and vegetables have been cultivated with fertilizer, you are most likely going to be low on magnesium. And if you are low on magnesium, you are going to have high blood pressure, you are going to have diabetes, most likely you are going to have issues with systemic inflammation. Your blood pressure is your blood cholesterol is likely going to go high. In fact, according to the US National Institute of Health, NIH, this is the US version of Federal Ministry of Health. They call theirs National Institute of Health, NIH. According to the NIH, magnesium controls about 300 enzymatic reactions in the human body. 300 enzymes depend on magnesium as a cofactor. First of all, I'd like us to consider, let us discuss this a bit so that you will see the difference between us and our ancestors. They were remarkably healthy. Now, in the production of energy, you need magnesium to to produce ATP. ATP, adenosine triphosphate, is the chemical energy of the body. You need magnesium in the synthesis or in the production of ATP in your body. That is one. Again, ATP as a molecule in and of itself is not stable. So, in medical science, you don't say ATP, you say magnesium ATP complex. It's a very unstable molecule. It needs magnesium to stabilize it. Now, in the event of magnesium deficiency, in fact, we are talking about subclinical magnesium deficiency. It's not easily apparent. You don't know it. It's a very difficult kind of deficiency to identify. Subclinical magnesium deficiency. I will explain that in the next few minutes. So, in the event of magnesium deficiency, which is occasioned by poor dietary intake, we're not getting enough of magnesium from our diets because of our farming methods, which we have changed from what we inherited from our ancestors. Somehow, we were convinced that our ancestors were not civilized. Therefore, because we use fertilizer, according to Professor L.G. Lombin of Ahmadu Bello University, we are magnesium deficient. And when you are magnesium deficient, the magnesium ATP complex is going to lose integrity. What will happen is that when this complex falls apart, ATP is somehow going to downgrade to ADP, adenosine diphosphate. Your energy level will begin to reduce. That's why in our time, a man at 60 is already using walking stick, whereas his grandfather at 85 was driving bicycle. The energy level is different. That is one on energy level. Remember that the U.S. Ministry of Health or the U.S. National Institute of Health said that 300 enzymatic reactions, 300 reactions of enzymes in the body are dependent on magnesium. I just showed us one from ATP. The second one which we must look at concerns high blood pressure. Because magnesium ATP complex has fallen apart, you are not going to be able to regulate your calcium channel. Your calcium channel. Now, amlodipine, which is a standard drug given to those who are hypertensive, is a calcium channel blocker. Look at what it means. This is a normal blood vessel. Now, when calcium ions begin to enter into the vascular smooth muscle, I mean this. For our blood vessels, there are smooth muscles that surround them. Smooth muscles surround our blood vessels. Now, when calcium ions enter into these smooth muscle cells, into the cells of these smooth muscles that surround the blood vessel, it's going to make the blood vessel to contract. So it will narrow. And when your blood vessels begin to narrow, you are going to have high blood pressure. So when you take amlodipine is a calcium channel blocker. What it will do is that it will block the calcium channels on these cells and prevent calcium from entering into the vascular smooth muscle cells. Vascular means it is in the blood vessels. Smooth muscles because they surround the blood vessels. So amlodipine is a vasodilator. It widens blood vessels by blocking the calcium channel. Once it blocks the calcium channel, then your blood vessels are going to relax or widen again. And when they widen, your blood pressure is going to normalize. But you have to ask yourself this simple question: how were you able to regulate this calcium channel before you got hypertensive and then you now have to depend on amlodipine to help you block the calcium channel and return your blood pressure back to normal. How did you do that before? You were able to do that you by way of controlling the potassium sodium potassium pump. I don't know if you can see that. So you regulate the sodium potassium pump, and by extension you control the calcium channel. So how did you regulate your sodium potassium pump before? It was by way of phosphorylation. It is through an enzyme called sodium ATPase. So once you are low on magnesium, this enzyme is not activated. This enzyme depends on magnesium as a cofactor. Once this enzyme is not activated, you will lose your ability to regulate this sodium potassium pump. And if you cannot control this pump, you cannot control your calcium channels. When they are open, calcium ions will enter into the vascular smooth muscle cells. They will cause your blood vessels to contract, to narrow, and then your blood pressure will go up. That's why you need amlodipine. That's the second one. We are going to 300. The next one, which we may not spend time on, is HMG CoA reductase. HMG CoA reductase. This is an enzyme that helps control your cholesterol levels. Again, there is the LCAT. There are two of them. Lecithin cholesterol acetyltranspeptidase. These two enzymes regulate your cholesterol production, and everything about cholesterol in the body depends on these two enzymes. When you are, if your cholesterol levels are high, I don't know if I should go into that. It will take us a little time. Maybe I should discuss it a little. Now, this is HMG CoA. This is mevalonate, and then this is HMG CoA reductase. In the biosynthesis of cholesterol, the way the body produces cholesterol, this conversion of HMG CoA to mevalonate is a rate limiting step. It is the most important step. So if you must catch the production of cholesterol, if you must stop it, you have to stop it here. This conversion of HMG CoA to mevalonate is catalyzed, or what speeds up the reaction is an enzyme called HMG CoA reductase. Once it reduces this HMG CoA to mevalonate, you can no longer control the production of cholesterol. Now, if your cholesterol levels are high, they are going to prescribe for you a statin drug like atorvastatin, simvastatin, rosuvastatin, and all the statin drugs. All of them. They are called, their chemical names are HMG CoA reductase inhibitors. Let us put an I there as inhibitor. So what they do, all the statin drugs, what they do is to inhibit this enzyme. When they inhibit this enzyme, it can no longer convert HMG CoA to mevalonate. And when this conversion is stopped, you can no longer produce cholesterol, or the level of production of cholesterol in the body will drop. Therefore, your cholesterol levels will normalize. This looks like a happy ending, but it has its own disadvantages. One of them is that cholesterol is not completely all bad. In fact, we cannot live without cholesterol. The gray matter in our brain is 95% by weight cholesterol. For men, cholesterol is involved. This pathway from mevalonate, you produce cholesterol, you produce bile salts, which helps us in digestion. You also produce hormones somewhere down the pathway. For instance, for men, testosterone, which is the main reproductive hormone, is 95% by weight cholesterol. Therefore, if you are taking certain drugs to block the production of to block the production of cholesterol, you are also blocking the production of testosterone. So the man is likely going to complain of erectile dysfunction and low libido. Bile salts will also get low. Therefore, the man might have issues with indigestion. And of course, certain drugs, according to the US FDA, one of the side effects of cholesterol is confusion, Alzheimer's disease. So when a man is placed on cholesterol long term or certain drugs long term, it may likely produce a situation where the man in old age can no longer recognize his wife and his children. He might eventually have issues with his cognitive ability. Therefore, the question now is, before your cholesterol levels went up, how were you able to manage cholesterol? Remember that not all cholesterol are bad, like I said. You also have the HDL cholesterol, which for a lack of better word, we can say is the good cholesterol. The one you don't want is the LDL, which they call the bad cholesterol. And of course, the very bad cholesterol is the VLDL, the very low density lipoproteins. Now, it is the job of this enzyme, LCAT, to keep the good cholesterol up, which you need for a healthy heart and a lot of everythingness in the body. This LCAT keeps the good cholesterol up and the bad cholesterol down. So when your cholesterol levels are up, if the doctor tells you your cholesterol level is up, it means that LCAT has stopped working. Now, what made it to stop working? These two, HMG-CoA reductase and LCAT, cannot do their job in the body if in the absence of magnesium. They must require magnesium, who is their childhood friend or their cofactor, to activate them to do their job. Therefore, in the event of magnesium deficiency, these two enzymes may likely not do their job, and therefore your cholesterol levels are going to go up. I wish I could have gone into COMT. From here, you will see mood orders, catecholamine, O-methyltransferase. From here, we can trace mood disorders. That's why a hypertensive patient, let me show you now. So, magnesium deficiency can make you hypertensive. It can make you hypertensive because you cannot regulate your calcium channels. It can make your cholesterol levels go up because you cannot activate these two enzymes. It can also make you have a sleepless night because COMT is not activated. COMT controls other neurotransmitters like serotonin, which is the happy hormone. The sleeping hormone also, melatonin, is here, and a lot of other hormones. This all regulated by COMT. Again, COMT functions also as a phase 2 enzyme, and as a phase 2 enzyme, it does the job of detoxification, and it detoxifies by way of methylation. And one of the toxins that COMT detoxifies by way of methylation is high level of estrogen. So, in the event of magnesium deficiency, because our fruit and vegetables are cultivated with fertilizer, we don't have enough magnesium to activate COMT. COMT cannot detoxify estrogen. For men, the man high level of estrogen can become bad, and if estrogen levels gets too high and turns into bad estrogen, the man is going to have prostate enlargement. Have you noticed that the issue of prostate enlargement has become a serious issue in our time? Have you wondered how our ancestors were able to manage their prostate without all the drugs that we have today? How? They had magnesium, they had minerals in rich supply. For women, if COMT is not activated, it will not detoxify excess estrogen. Excess estrogen turns into bad estrogen, and for women, it can lead to breast cancer, and also it can lead to polycystic ovarian syndrome. So this is the much we can discuss on magnesium deficiency. Now we are talking about areas of interest. Why high blood pressure has become such a serious challenge in our time that we can't seem to grapple with it. The next thing I want us to discuss very well is nitric oxide. Nitric oxide is a very important gas. In fact, in 1992, first of all, in 1980, an American professor, Luis Ignaro, discovered nitric oxide. In first, he called it EDRF. He didn't know what it was. Endothelial derived relaxing factor. He said it relaxes blood vessels. It was in 1986 that Professor Ignaro, working independently, discovered that EDRF is actually nitric oxide. That same year, another American scholar, Robert Fishgott, discovered also that EDRF was nitric oxide. In 1992, nitric oxide was called the molecule of the year because they discovered that it has several jobs it does in the body, a lot of work it did in the body. Therefore, the academic journal called Science called it the molecule of the year. In 1998, 3 American scholars, one of them is Professor Ferid Murad, the next is Luis Ignaro, and the third is Robert Fishgott. 3 of them, on the 12th of October 1998, were awarded the Nobel Prize for the discovery of nitric oxide and what it does in the human body. If endogenous production of nitric oxide, what that means is that if the production of nitric oxide in your body is at its optimum, if it is not frustrated by inflammation, you cannot develop high blood pressure. That's a fact. And in fact, what is it about nitric oxide that rises to the level of a Nobel Prize? What is it about nitric oxide that should attract these 3 gentlemen a Nobel Prize? That answer, we can get it from the New York Times magazine of October 13th, 1998, the very next day. Let me read briefly for you what New York Times magazine said in October 13th of 1998. They said 3 American pharmacologists were awarded the Nobel Prize yesterday for their surprising discoveries of how natural production of a gas, nitric oxide, can mediate a wide variety of bodily actions. What actions? They said these actions include widening of the blood vessels, helping to regulate blood pressure, initiating erections, battling infections, preventing the formation of blood clots, and acting as a signaling molecule in the nervous system or cardiovascular system. Did you see that? This is just a few. Battling infections. Later, we are going to run a series on infections, and you will see that the reason why Antibiotics are beginning to fail. The reason why the WHO is now concerned about the future of humanity in our fight against pathogens and bacteria is because we have ignored nitric oxide. The reason we now have a high prevalence of erectile dysfunction, the reason why our blood vessels begin to narrow and cannot widen. Therefore, the reason for the increase in high blood pressure is because of nitric oxide deficiency. I asked you before, which one makes more contributions to high blood pressure? Is it salt or is it sugar? I know you are going to say salt because that's what your doctors have told you. But in 1972, a British doctor called John Yodkin wrote a book against sugar. He called it, the book was entitled Pure, White and Deadly: How Sugar is Killing Us and What We Can Do to Stop It. His ideas were not as his theory was not accepted by the medical community because he could not produce the molecular mechanisms to validate his claims. Therefore, his ideas were expunged. He was not taken seriously. But today, time and research has proven him right. We must now go to Professor Richard Johnson. He is going to tell us, answer this ultimate question between salt and sugar, which one makes more significant contributions in the development and progression of high blood pressure. Professor Richard Johnson qualified as a medical doctor in 1978 and has been studying the kidney for more than 45 years, well above 40 years, until he became a professor in nephrology. He is a kidney doctor. He is a professor in kidney studies. Not just that, sometime last 2 years, a minister of the Federal Republic was made a professor. In fact, he is Professor Pantami. He was made a professor by a university in Southeast Nigeria. And many academics in Nigeria took exceptions to that investiture. They kept asking one question: what academic publications has he written? Professor Pantami was struggling to show us one paper in an international academic journal. Again, sometime last year, Pastor Olukoya of Mountain of Fire was made a professor by a university in Southwest Nigeria. And they said he merited that professor of biotechnology because he has published up to 120 or more academic publications. So one professor is struggling to show us one paper, one academic paper. Professor David Olukoya of Mountain of Fire, Professor Olukoya of Mountain of Fire has about 120 publications. Professor Richard Johnson has more than 800 research publications, and most of his research were funded by the U.S. National Institute of Health, U.S. Ministry of Health, by the government. So he was not funded by companies. So you cannot accuse him of conflict of interest. Professor Johnson understands the kidney very well. It took him 10 years and 7 months to discover that the problem with high blood pressure is sugar. It is not salt. In fact, he said that if you take a high salt diet, if salt levels in your food is high, it will increase the salt concentration in your blood by around 140 to 143 millimoles per liter. And then this slight increase in salt concentration is going to increase your blood pressure by 6 points, 6 millimeter mercury. Sorry, by the way, this is millimoles, not millimeter. So this slight increase in salt concentration in the body will increase your blood pressure by about 6 points. And he said, if your kidney has not been injured by inflammation, your 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 kidney will excrete this excess salt in the blood through the urine. It will excrete it through the urine within 4 hours, and your blood pressure will return back to normal. If your kidney does not do this, it means it has been injured by inflammation. Now, what causes the inflammation? Like I said, it took Professor Richard Johnson about 10 years and 7 months to discover what sugar actually does in the body. Now, when sugar enters, when you take sugar, when you take any of these sugar sweetened beverages, or like this, remember our ancestors did not see this. The sugar they had, the fructose they had, were in its natural form, in the fruit form, not in this highly processed, ultra processed form. When you take sugar, first of all, remember that sugar is made up of two components: the glucose and the fructose. Glucose is sweet, but not exactly too sweet. Fructose is the sweet molecule in sugar. That's the one we crave for the most. When you take sugar, fructose must be broken down by the kidney. Fructose must be broken down by the liver. And when it enters the liver, the first thing that happens to fructose is that you have to add a phosphate group to it. A phosphate group. And that phosphate group will come from our ATP. We mentioned ATP earlier. ATP, adenosine triphosphate. When you do that, fructose will become fructose 1-phosphate. What happens to ATP? ATP will downgrade to ADP. And this will continue to AMP, then to IMP, and all the way until uric acid is produced and released. So whenever you take sugar in this form or in any of its sugar sweetened beverages, you are going to produce uric acid as a necessary byproduct. Remember, we didn't continue with this metabolic pathway of the breaking down of fructose, of sugar. We took this branched off. The enzyme only picked one phosphate group from ATP and started breaking down ATP. So this is a side, is a byproduct of sugar metabolism. So when you break sugar down, you are going to produce uric acid. Once this uric acid leaves the liver and enters the bloodstream, it marks the end of the reggae. It is time to play the blues. This uric acid enters, when it gets to the kidney, it is going to an enzyme called NADPH oxidase. NADPH oxidase. NADPH oxidase 4. They are called NOx4. There are 7 of them: NOx1, NOx2, NOx3, NOx4, NOx5, and then dual oxidase 1 and 2. But within the kidney, the one you find the most is NOx4. When you activate NOx4 within the kidney, these are mechanisms that the British doctor in 1972 did not produce. Therefore, his ideas was expunged by the medical community. But now these mechanisms are out. So when you activate this enzyme NADPH oxidase within the kidney, it is going to produce in excess amounts of free radicals, especially superoxide free radical. This superoxide is going to attack nitric oxide, our most precious nitric oxide, to form peroxynitrite. And this causes injury. This peroxynitrite is highly reactive. It causes injury within the kidney. It injures the kidney, a low grade imperceptible injury within the kidney that makes the kidney lose its innate ability to excrete excess amount of salt through the urine. Remember that medical science says they don't know the actual cause of high blood pressure. Now, let that what I just described is actually written on paper, published by Professor Richard Johnson, like this. Johnson et al. Published this paper in 2002. It's entitled Subtle Acquired Kidney Injury or Subtle Acquired Renal Injury as a Mechanism of Salt-Sensitive Hypertension. And when they discussed the mechanism, how sugar injures the kidney, the first thing that happens is impaired renal nitric oxide bioavailability. What this means is that once the availability of nitric oxide within the kidney is tampered with, the microscopic blood vessels within the kidney will begin to narrow. And when they begin to narrow, the supply of blood is compromised. Blood can no longer flow through these very tiny and very microscopic blood vessels. When blood flow is frustrated, oxygen supply and nutrient supply to that part of the kidney is frustrated. And when that happens, when oxygen supply and nutrient supply are impeded, that part of the cells will begin to die. It's a low grade imperceptible injury. It happens after many years. So he actually discussed the whole system, how it happens here. There will be a low grade ischemia within the kidney. Ischemia is when blood flow is restricted. When that happens, there is a low grade injury within the kidney, and an injury that does not appear on a normal kidney function test. The fact is this: according to Professor Richard Johnson, if you are hypertensive, you do not have a normal kidney. Your kidney has been injured. It was injured by inflammation that was promoted through uric acid, and it is traceable to sugar. It is not salt. So, if you're hypertensive already, you must cut down on your salt intake because your kidney can no longer handle it. But much more, you have to be careful of sugar because sugar promotes systemic inflammation, which continues to injure your endothelium. Time will fail us to discuss this. We will take time to discuss this much later in details. Inflammation injures your endothelium, which is the inner lining of your blood vessels. That is the connection between sugar, between hypertension and cardiovascular diseases. There are other connections which has been identified by medical science. Again, it is not only Professor Richard Johnson that had discovered this. Other eminent scholars have also published along these lines, like James Di Nicolantonio and Sean Lucan. They published this paper some years ago. It's entitled The Wrong White Crystals. It is not salt, but sugar as etiological in hypertension and cardiometabolic diseases. It is not salt, it is sugar. That is as etiological in hypertension and cardiometabolic diseases. If you had kidney failure, if you have heart diseases, the role of sugar has been identified in research. Again, look at this one. Just a spoonful of sugar helps your blood pressure go up. Published on PubMed by Stephanie Nguyen et al. And many professors were involved in this paper. So it is now a fact among medical science, among doctors, that as in people who are really into research, that high blood pressure and other inflammatory diseases, other chronic diseases have been traced to sugar, not salt. So in essence, sugar promotes a chain reaction of inflammation which must be stopped. And even if you stop taking sugar now, not much is going to be, chances are that high blood pressure will not be reversed, because it takes nutrition to stop the chain reaction. You need to break up the damage that has been done, repair the DNA that has been damaged by inflammation, and then you can reverse hypertension. Hypertension is reversible, even though that's not a position that your healthcare providers may have adopted. Now, and by way of summary, we want to establish the next these facts. One, that nutritional deficiency leads to the development and progression of one that nutritional deficiency leads to the development, the progression, and the complications of disease conditions. Again, that more drugs and more chemicals will never compensate for nutritional deficiency. Drugs cannot compensate for nutritional deficiency. If your disease condition had developed because of nutritional deficiency, you need to supplement. You have to supplement. Again, that because we no longer get the same value from fruit and vegetables as our ancestors did, we need to supplement. Therefore, when a doctor promotes only drugs and tells you to leave fruit and vegetables, it is not the right kind of advice. That doctor is not a soil scientist. He is not a crop scientist like Professor L.G. Lombin. He has never at any time in his training performed a soil sample or a crop sample analysis. Therefore, it is not in his place to tell you to leave supplements and focus only on fruit and vegetables and your drugs. Our fruit and vegetables are no longer what they used to be. Therefore, we are mineral deficient. We are nutritionally deficient, and we have to supplement. In fact, there was something I did not tell us about magnesium. Because of magnesium deficiency, if you want to supplement on it, you waste your time if you come and you buy synthetic, magnesium supplements. The best way to supplement on magnesium is on fruit and vegetables. And if the ones you find in the market may have been planted with fertilizer, therefore they lack magnesium, you have to supplement. Again, if you go to the lab and they take your blood sample and they search for magnesium, they are wasting your time. You know why? Because the magnesium content in the blood, the serum magnesium, is only 1%. Is only 1%. 1% of total body magnesium. 1%. The rest of the 99% of magnesium content in the body are intracellular. They are within the cells. And up till now, there is no clear biomarker. There is no clear biomarker in medical science for testing for intracellular magnesium deficiency, which accounts for 99% of magnesium in the blood. So you need to supplement. So whatever supplement you must get must contain magnesium in a whole food matrix, not magnesium that has been isolated and is being sold as tablets. The one that is still inside the plants where they occur. That's magnesium in a whole food matrix, and that's the magnesium that will quickly dissociate, break up in your digestive tract and release the magnesium ion. This magnesium ion is a type. This magnesium ion is the type of magnesium that crosses through the blood-brain barrier, enters the brain, and from the brain it is circulated into the body. If you are having any heart disease whatsoever, you are low on magnesium. That is a fact. One of these days, right here in Pure Health Revolution, we will take time and do a detailed study on magnesium, and I will show you all the publications that validate everything I have said so far on magnesium. Therefore, you need to supplement. But Hippocrates, 2,500 years ago, Hippocrates said, make food thy medicine and make medicine thy food. Right here in Pure Health Revolution, we encourage you to make food supplements a part of your medicine, so that medicine will not become your food. As far as the human body is concerned, what nutrition cannot do does not exist. Therefore, in Pure Health Revolution, it is about deliberately determined effort to bring you to the position where you will make nutrition the very foundation of your primary health care. You must make nutrition the very foundation of your primary health care. For a broad spectrum nutritional supplement, for a research-based nutrition, okay, for a research-based recommendation of a nutritional supplement that could help to complement the effort of your drugs, please, you can send us a message on the WhatsApp number on your screen. Also, if you have found value in this video, please kindly comment, please kindly share. When you share this video, it will be on your timeline so that you will not miss it. If you don't have time to watch it now, you can find it also on your timeline again and watch it next time. I want you to take this very seriously. Hypertension is a medical emergency. High blood pressure is a medical emergency. Therefore, if you are hypertensive, don't take chances. Take supplements. In the end, it is your health. It is your choice.